Hi, my name's Brett Threlkill. I'm the Applications Manager at Advanced Illumination. I'm going to talk a little bit about how modular machine vision lighting can enhance system flexibility and reduce development time of your application. This presentation will explore key design considerations of modular lighting, configuration options, some of the trade-offs with modular systems, and I'll highlight how this approach can support long-term system adaptability in industrial automation. By allowing in-field adjustments through interchangeable optical elements, modular lighting systems help engineers adapt to varying inspection requirements. Industrial inspection, quality control, and robotics all depend on machine vision, which has become a key component of modern automation in manufacturing. Delivering a machine vision system that meets the application requirements on schedule and on budget demands that engineers balance development time, system performance, and cost during the design phase. Choosing the right light for machine vision can make or break the application. Engineers need to understand how a light's wavelength and geometry influence object-light interactions and must carefully evaluate their inspection environment. The ultimate goal is to enhance image contrast and achieve robust vision system performance. When designing a vision system, making the perfect illumination choice can be challenging. Submitting an application evaluation to a machine vision lighting supplier requires that engineers provide as much information as possible. Evaluation starts with a part description and inspection goals, what you're inspecting and what you're inspecting it for. It's important to characterize the features that need to be detected. For example, is the target flat or curved? Is it smooth or are there topographical features? Is it specular or does it have a matte finish? As well as any other appearance variations. Solving an application can sometimes even require the submission of actual samples of good and bad parts. The process of specifying the right machine vision light will likely also include information on inspection cycle times, desired exposure time or shutter speed, as well as the minimum and maximum working distances, your field of view, space constraints within the equipment, and other essential factors, all with the goal of making your application effective, consistent, and robust. Modular machine vision lighting solutions address some of these challenges by meeting a variety of unique application requirements. Modular lighting can offer different wavelengths and sizes, as well as optical accessories. These options make it possible to alter lighting geometry, pattern, beam angle, and usable field of view to provide added flexibility in the field. Perhaps no other aspect of vision system design and implementation has consistently caused more delay, cost overruns, and general consternation than lighting. Proper machine vision lighting plays a crucial role in enabling machines and robots to see and interpret the world around them. It enhances the vision system's ability to acquire high-quality images, which positively impacts the accuracy and reliability of image analysis. Recently, modular machine vision solutions have gained popularity by offering interchangeable components that provide flexibility and adaptability in the field. Modular systems provide a level of customization that meets a variety of application demands. Modular lighting can be adapted on the fly to meet specific requirements by swapping out lenses, light conditioning films, or other components. Instead of trying to figure out what light is right for the application, especially in cases where all the requirements may not be 100% nailed down, modular lighting allows engineers to work with a light that can be adjusted in the field to meet any need. Offering several advantages over traditional fixed lighting systems, modular lights can be an attractive option for various industries and applications. Machine vision applications significantly vary based on object characteristics, such as texture, color, camera orientation, environmental conditions, and several different lighting techniques. As such, vision system designers increasingly seek modular illumination solutions. The benefits of modular lighting include simplifying the light selection process, reducing development time, providing adaptability and customization options, as well as cost reduction and future-proofing vision systems deployed in live production environments. One of the primary benefits of modular lighting is simplifying the process of specifying an optimal light for a given application. This is especially helpful for applications where all of the requirements may not be known at the start of the project. Because modular lighting can be adapted for various applications, a single modular lighting kit can be tailored to meet a range of application requirements, thus ensuring optimal performance across various scenarios. The first step is to review the technical inquiry form for what's being inspected and what it's being inspected for. What are the goals of the inspection? What is the size of the target? And what is the anticipated field of view? How are the objects being presented? Are they stationary, moving, always presented in the same way? What are your light control requirements? Do you require constant on lighting, or will strobing be required? Are robotics involved? Is the object flat or curved, specular or diffuse? What about the background? What type of camera is being used? Color, black and white, line scan? After analyzing the application requirements and any sample parts sent in for testing, lighting suppliers often test the light before making a recommendation and shipping a demo unit or loaner to the customer. Sometimes, due to incorrect assumptions and bad project scope or misconceptions, the demo unit may not fulfill all of the application requirements. In such instances, reevaluating, updating technical information, revising the lighting solution, and shipping demo units back and forth can eat up weeks of development time, throwing the project off schedule. Modular machine vision lighting system kits provide the optical accessories required to solve many applications. This minimizes the need and the cost to obtain further demo lights and can help reduce the time it takes to develop the application. Inspection of different parts requires various capabilities and features from the illumination source. Modular lighting systems offer adaptability to different spaces and environments, as well as extensive customization options that allow users to create various unique compositions. The flexibility that interchangeable optical elements and light conditioning films provide allows the tailoring of machine vision lighting systems to meet your specific application requirements. For example, direction turning film can be used to create a dark field effect where surface features like scratches, bumps, or wrinkles need to be highlighted against a darker background. This oblique lighting technique is particularly useful for inspecting planes where subtle features or imperfections need to be detected. Elliptical film spreads light asymmetrically, which can diffuse a line of LEDs into a smooth line. By diffusing the light, elliptical film can help reduce specular reflections and glare, and can enhance contrast, making it easier for machine vision system to distinguish features of interest. By packing many capabilities into a single lighting unit, modular machine vision lights provide application engineers with a tool that can be calibrated to meet the exact requirements of the application. Many application engineers rely on a well-stocked machine vision lab that includes several different types of lights with a variety of lenses and light conditioning materials to work with. Modular lighting can save money by replacing numerous lights with a single unit that allows engineers to adjust beam angle, beam directionality, polarization, diffusion, beam shape, and more in the field. This allows engineers to achieve various lighting techniques without purchasing multiple lights and simplifies the light selection process and reduces development time. This video is a great representation of what modular lighting can do and the options that it can provide. Even after a machine vision system is complete, changes may still be required during the final installation in the manufacturing facility due to ambient lighting conditions. Part and process changes can impact the performance of an installed machine vision system as well, causing it to fail in the live production environment. By offering the modular capabilities in the field, Apps engineers have the flexibility to cope with such challenges and quickly adapt the illumination to accommodate these types of future changes. The effectiveness of modular machine vision light is determined by the interplay between its optical performance and its configuration mechanism. The choice of technology affects the light's output efficiency, uniformity, and ease of use in the field. Three primary designs dominate the market: position-adjusted spherical lens arrays, swappable diffusers, and swappable total internal reflection, or TIR lenses. First up are the position-adjusted spherical arrays. These systems use a single array of spherical lenses, and the beam angle is adjusted by mechanically changing the distance between the lens array and the LEDs. One benefit is that they are relatively simple design, and one array can offer different beam angles by adjusting its position. However, they are less effective in maximizing light transmission and uniformity compared to the TIR lenses. Another approach relies on swappable diffusers. This method offers a fast and simple way to alter light dispersion, but the convenience comes with significant compromises. This design is the least efficient optically. It suffers from two distinct sources of loss: poor coupling and low light transmissivity inherent to the diffuser material itself, resulting in unfocused illumination and a substantial reduction in output. Swappable internal reflection, or TIR lenses, represent the most effective approach, engineered to maximize both performance and configurability. Each TIR lens is designed for a specific beam angle and fully encapsulates each LED, ensuring better optical coupling. This maximizes light transmission and produces a highly uniform output, a critical advantage in demanding, high-speed applications where a TIR system can be nearly twice as efficient as a spherical lens system and provide 4 times the efficiency of a system using swappable diffusers. This design is available in 2 configuration styles: individually swappable lenses. This option allows for the design flexibility of a modular system with the performance benefits of a premium TIR lenses, but requires changing each lens one by one, which can be more time-consuming but can be less expensive. And swappable lens arrays. This option fixes multiple TIR lenses into a single swappable holder. It provides the ideal balance, combining the rapid configuration of swapping a single component with the high optical efficiency inherent to the TIR design. This delivers bright, uniform illumination while offering efficient field configurability, but can add to the cost. Another option, commonly found with the modular bar lights, is the convenience of the embedded controllers. These internal controllers offer basic control options such as constant on and gating on and off, dimming, and strobe overdriving the lights. While this feature offers the plug-and-play option, it does lack some of the more sophisticated choices that an external controller can offer, all of which I talk about in another presentation called A Guide to Selecting an Optimal Machine Vision Lighting Controller. Modular machine vision lights offer numerous benefits, including simplifying the light selection process, reducing development time, adaptability, potential cost reduction, and future-proofing the machine vision system. By understanding the key factors to consider in modular lighting design, vision engineers will be better able to harness the full potential of modular machine vision lighting. Thank you for your time. If you would like to take a more in-depth look at the subject, please go to the Advanced Illumination website and download the benefits and trade-offs of modular machine vision lights white paper. Have a great day.